You got it? Okay, let's begin with a word of prayer. Dear Heavenly Father, we thank you for this day. Again, Lord, I thank you for the lovely weather. I pray you be with us today. Help us to, again, Lord, glorify you in what we do, Lord. And I just pray the students do their best on the test tomorrow, that you be glorified from their studying, Lord. In your name I pray. Amen. Well, I am sick, but that's okay. We have class participation tomorrow, which always makes me feel better, so it's good. I do have your mission 6. Let's see here. Stephen, Ben. Do you see him later or sometime? Savannah. Alex Vogel. Alex. No. He's here. He's just not here. He's here, but he's not here. This is yours. Austin. Sorry. It didn't survive. Tristan. I thought I saw him. Daniel. Luke. I'm not sure if that's 1 or 2. Peter. Terrence. Andrew. Andrew. Is there an Andrew here? Oh well. See, if you guys would do your homework on like slightly heavier stock paper, we wouldn't have these problems. Yeah, I mean, why don't you just do your homework?
Don't worry.
Sorry. Barrett?
Give me the whole back row.
Oh, yeah, actually. Good point. Is Patrick back there?
I'll take Danica's spot.
Carl? You're on the bottom of the stack there, yeah.
Do you have Danny?
Who? Patrick? Alex Vogel? Alex? Jameson? Yeah, there you are. Barrett? And this is behind our cameraman for today. All right, I think that's it. Yes? What's that? It was both bonus and required. That means you could have lost 2 points for not doing it, but you would also have gained 7 points for doing it. You got what? I'll have to look at it after class. I'm sorry, you guys. I did email him to try to get it to happen. I don't know what's. I'm not sure how it shook out exactly, but I did tell him 5 bonus points for that if he did it right. Most likely, yes. Don't make me cough. Oh, wonderful. There is a test tomorrow. I foresee myself being sick this week, therefore we are going to take off Wednesday, if there's no objections. Okay, good. And then Thursday we'll pick back up on Green's theorem. So don't worry, we won't be behind. The Friday before break we're skipping. Yeah. All right, so that's not this Friday, is it? Okay. Next Friday, yeah. All right, so are there any questions about the class participation tomorrow that you're all involved in? The test is the ultimate form of class participation, actually. You guys didn't know that? No? You don't think of it that way? Oh. Oh. Yeah, those people are wrong. Yes? Can we do a Lagrange multiplier? Sure, I guess. Let's find min. I just made this up. It's likely to be awful. What's that? I didn't pick a point. Did I pick a point on the ellipse? That would be bad. Hmm? The ellipsoid is nasty. I think this one is going to be manageable since I'm not doing it for an arbitrary ellipsoid. I'm doing it for a specific one, so I still have hope. It may still be nasty. We'll find out. So what do we have? Our objective is what? So we've got some ellipsoid, right, which is x squared plus 2y squared equals to 1. And I pick a point on there, say xy, and I'm trying to minimize this distance, right? But I can minimize the distance squared just the same, so that's x minus 3 plus y minus 4, right? So method of Lagrange multipliers will help us out here. The gradient of f should be lambda times the gradient of the constraint. What's the constraint? What's the constraint is this right here, right? So the constraint we have 2x and 4y, it looks like, for the gradient of g. And so I have to solve these equations. X minus 3 is equal to lambda x, and y minus 4 is equal to 2 times lambda y. Did I do something wrong yet? Odds of me doing something wrong today, very, very high. I don't even want to, like today, my earlier lecture today was so awful. I don't think I'm even going to post it. I'm going to have to like redo it. It's just so pathetic. It's just so awful. I really have no expectation of being able to do the simplest of calculations in this review today. Yes? Oh, I divided by 2. You mean where? Oh, here? Oh, no. The distance from this point to that point is just the sum of the square root of the sums of the differences of this, x minus 3 squared plus y minus 4 squared would give me the distance squared between the point on the ellipse and the point 3,4, right? So there wouldn't be a 2 there. Yeah. There's an asymmetry between the distance function and the constraint function. Okay, so what do we got? We got to solve these equations, right? I don't know. There's different ways to do it. The sight of lambda offends me. I like to divide these equations to get rid of it. That may or may not be helpful. We'll find out soon. So y minus 4 over x minus 3 is equal to what? 2y over x and I now regret my life. Okay, so xy minus 4x is equal to 2yx minus 6y. And I think at this point you can realize that this is not a reasonable test question. Okay, so this is yx is equal to what? Let me put everything on one side anyway. I get yx minus 6y plus 4x is equal to 0. I guess that's not too bad. That gives me y times x minus 6 is equal to minus 4x. Therefore, y is equal to 4x over x minus 6. And then I can go back up in here. Go back up to there and substitute that in. So what I've got is x squared plus 2 times quantity. Yeah, although fortunately that wouldn't have hurt me because I was about to square it to oblivion. Minus 4x over x minus 6 quantity squared equals to 1. Oh, is it still sixth order? No. This is just quartic. Oh, wait a minute. No, you're right. Well, no, I think it's just quartic. So x squared, 1632 x squared divided by x minus 6 quantity squared equals to 1. So x squared times x minus 6 quantity squared plus 32x squared is equal to x minus 6 quantity squared, which is x squared minus 1 times x to x minus 6 quantity squared plus 32x squared equals, that didn't help, which is x squared minus 1 times x squared minus 12x plus 36, somebody stop me, plus 32x squared is equal to 0. Blah, 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 blah. It's quartic, right? So its solution in closed form in terms of a finite number of algebraic operations has been known for about 320 years or so. No, I'm sorry. I don't know, when did Euler write that book? I don't know. It's been a while. But that said, sorry. It's all Tyler's fault. What would be a more reasonable Lagrange multiplier problem for the test? Distance from the point to a plane. Yeah, that's a good example. Or something like, how about maximize, x squared plus 2y squared on x squared plus y squared equals to 4 or something like that, These come out to linear equations as opposed to what just happened to us. Or another problem, another example, something like, here's a parabola, and find the point on the parabola closest to a point off the parabola is another one that's not too bad, I don't think. Anyway, you had some homework problems, so, Obviously not the ellipsoid problem, right? I mean, we've established that I shouldn't have done that either. Okay, now that we've established that, maybe there's another question. Help me to stop talking about this, please. Yep.
Can we do a Taylor series problem?
A Taylor series? In what sense?
Like the ones that we had to expand around and before we learned the Lagrange multipliers. You know what I'm talking about?
Yeah. Certainly. How about something like f of xy equal to the sine of x cubed minus the cosine of y plus x squared. Find expansion 0, 0. And if it's a critical point, classify it min, max, or saddle. Okay? So find the expansion. And to be more clear, I'll say to fourth order, just to give us a reasonable target. All right? Okay, so if you got something like this, you can just pick on them one at a time. So like the key things to know, of course, is what? Sine of u is u minus 1/6 u cubed plus da da da. Cosine of u is 1 minus 1/2 u squared plus 1 over 24 u to the fourth plus da 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 da. I mean, 24 is 4 factorial. 6 is 3 factorial. Sine x cubed then, up to fourth order, like I don't care about the cube term, because the u cubed term would be ninth order in x. That's irrelevant to our current purpose. So I just need the first thing in sine, the u, which is x cubed. That's all that survives of the sine. Cosine, parentheses our friend here, so I've got 1 minus y squared minus 1/2. Oh, sorry, I can't do math. All right, 1 minus 1/2 y squared plus 1 over 24 y to the fourth. Oops, we're to fourth order. Okay, we'll stop right there. And then x squared is x squared, so there's kind of nothing to do there, is there? So you reorder the terms. Think about our life. We got minus 1 plus 1/2 y squared plus x squared. I usually would write the x squared first, but I didn't see it in time. And I'm not about to erase that, so there it is. Anything else quadratic? No, that's it. What's the first quartic thing? Where's the third order terms? There. Oh man, I can't believe I didn't tell that joke today in complex. Oh, you don't understand what I just realized happened. Oh man, today was I can't believe I didn't tell that joke this morning. This is a horrible day. You just don't even know. It's like a favorite joke. I can't tell it in here, you guys won't get it. So.
There should be the x cubed after the x squared.
Why would there be that? Oh, yeah. Because it's there. Duh. Okay, thank you. So there is the expansion of f of xy to fourth order. Yep. Uh-oh.
When you got sine and you put minus,
Okay.
reverse the sign.
Yeah. There's the sines and the sines. Yes. Okay, so that's the power series expansion to fourth order. Now how do we do the critical point analysis? It's pretty simple here, right? So you look at this, and you can see that f x 0, 0 is equal to f sub y. 0, 0 is equal to 0 because there are no linear terms, right? So therefore, 0, 0 is critical, or stable point, I think as your text calls it. All right, it's a place where the gradient 0, or nabla, f is 0 if we like. And, oh goodness, I don't even really need the second derivative test here because I can just look at this and say, aha, look at the Hessian term. It's the sum of squares. That's manifestly a minimum. Because if I look at this function close to the critical point, I've got minus 1 plus 1/2 y squared plus x squared, and that thing is getting bigger as you go away from 0, 0, because you're adding a square of a real number. Now, that said, we could look at the Hessian. We could look at the second derivative test, the d, right? So d at the point 0, 0 would be fxx fyy minus fxy squared, right? And here, it's probably useful to do this anyway, just for exercise. I mean, you need to do this in something where you have mixed terms, right? If you had something that come out to like x squared plus 3xy minus y squared, 7 plus x to the 437 or whatever it is. If that had happened, then we'd have no choice but to look at the d to analyze something with the mixed terms. My point is to use, we don't absolutely need to analyze the d here to make the conclusion that it's a minimum. I'm just doing it for the sake of a more complicated example like this one. So what is fx? X? No, it is 2. 2. And because remember, what you got to compare it to is dot 1/2 fxx 0, 0, x squared, and so forth. I mean, that's the term in the power series. So you got a half. So if there's a half there and there's a 1 here, that means there was a 2. And how about fyy? 1, yeah. What's fxy? 0, right? So this is greater than 0, so therefore local min as fxx is what? Okay. Yeah?
How did the sine of x cubed just work out to x cubed instead of what you have there for the sine of u?
U is equal to x cubed.
What about the minus 1 over 6 u?
U is equal to x cubed. That's the first term in the sine series. I mean, there's also a minus 1/6 x to the 9th, which is what you're asking me about, but that's the next term. Yeah, it's a substitution that's messing. It's an unfortunate fact that we have cube and cube here, but they're different cubes. Yes?
How you got the 2 and 1, right?
Yes, the coefficient of x squared is twice whatever the second derivative is of x. Because if you compare it, whatever number is there, it has to be fxx divided by 2. So if I get my coefficient of x squared as 1, that means that I had to have a 2 there, because 2 divided by 2 gives me back 1 again. Like here, if this was my expansion, suppose this was just given to us. What is, this tells me that fxx at 0, 0 is equal to what? F of xy at 0, 0 is equal to what? Fyy at 0, 0 is equal to what? Yeah, 2. I'll do the easy one, minus 2. Middle one's 3, right? Because there's a distinction with the xy terms, you get it 2 different ways. Yeah, so this one, what would the d would be 2 times minus 2 minus 9, which would be equal to minus 13, which would be less than 0, so therefore f of 0, 0 equals to 7 is a saddle point by the second derivative test. Again, second derivative test really is nothing more than the application of the multivariate power series paired with a theory of orthogonal, the theory of symmetric, what's the word? Spectral theorem to encapsulate it, which we proved with Lagrange multipliers that one day over there on the sideboard. Here's another question. Yes, sir.
Can work on a problem similar to number 81 on Mason's fit?
Excuse me. 81 or 91, did you say?
81.
Oh, yeah, 91's not even here, is it? Oh, yeah. So your question generically is find the volume bounded by some planes, right?
I'm just trying to get the balances out of it.
Yeah, yeah. I mean, of course, you could reasonably modify this problem too, right? I mean, like, surely we could also work this problem with, you know, z equals to 1 or something like that, right? Well, I mean, maybe not that, but, well, let's just figure what this one out looks like. So what do we got to do? My starting point is to try to just kind of picture it. Of course, this is z is equal to 2 minus x minus 2y, right? So let's see here. What are the points it intersects the axes with? I think it's going to be an octant 1. The one in your homework is not, unfortunately. If y and z are both 0, x is 2. If x and z are both 0, y is 1. If x and y are both 0, z is 2. Right? So I suggested that the way to do it was to try to knock it down, to reduce the third dimension to start with. So basically to figure out what's the projection of the thing down to here to this region, right? So what's this line right here? That's where z is equal to 0, right? So that if we put 0, 2 minus x minus 2y equals to 0, that's the equation of that line in the xy plane. So let's see here, what's this? 2y is equal to 2 minus x, so y is equal to 1 minus 1/2 x, I think. So it starts up here at y equals to 1, and it goes down to y equals to 0 at x equals to 2. Right? So what do we have? 0 less than or equal to 2 minus x minus 2y less than or equal to z, right? I'm an idiot. Other way around. Duh. Z, the top is 2 minus x minus 2y. Then here I need to do some thinking still, right? I have 1 less than or equal to x less than or equal to 2, and 0 less than or equal to 1 minus 1/2 x less than or equal to y. Again, I made the same mistake. All right. Oh, yeah, 0. Sorry. Thank you. So we have 0 less than or equal to y less than or equal to 1 minus x over 2, and finally 0 less than or equal to x less than or equal to 2. Put these together, get the integral 0 to 2, integral 0 to 1 minus x over 2, integral 0 to 2 minus x minus 2y. Now if we did this right, we should only have 2 variables in the bounds, right? Not 3. One time I had 3. That was wrong, obviously, as I emailed you guys about. And then you integrate. The first integral is easy. second integral stings a little bit. Let's see here. With respect to y, I've just got 2 minus x times 1 minus x over 2 minus 1 minus x over 2 quantity squared. I don't know. Maybe I'll just multiply them out and subtract them. Whatever. 2 minus x minus x plus 1/2 x squared minus 1, parentheses, minus 1 minus x plus 1/4 x squared. Here. What do I got? 1 minus x plus 1/4 x squared dx, which is what? 2 minus 1/2 of 4 plus 1/12 of 8. Whatever that is. I'm sorry, I shouldn't waste your time doing this integral. I mean, the point is the setup, really, right? Although if you disagree with my integral, I'd like to know now as opposed to the end of class. We can all agree that my calculations should not be trusted on this day, right? I mean, so the spirit of the calculations is right. I may have done some arithmetic wrong. I wouldn't be terribly surprised by that. How would this problem be different? Can you think of any way to modify this problem a little bit in a reasonable way? What if I said, like, instead of x equals to 0, what if or instead of y equals to 0, what if I said, like, y equals to 0, and what if I added something, and what if I tacked on this list y equals to 1, what would that change? Nothing. Oh yeah, you're right. Fine. Because I hate fractions, I'll put it on x. X equals to 1 there. Ha ha. Ha! Take that. What would that do? That would put x equals to 1 as a boundary. That would be this thing. So then we'd just be looking at that, and this would be cut off. This whole piece would be, we have to, that's lost, right? So, I mean, yeah, it changes the x integral from 0 to 1, but it does more than that. It changes this picture also, right? And maybe you're right. Maybe that's all it does, because it's still the same. It's like this then. Yeah, I guess that's still just that has to go to 1. Ah. Yeah, right. If I had put in y is equal to 1/2, that would have put a monkey wrench in our plans there, so to speak. My point to you is I want you to understand the concept of what we're doing. I wouldn't assume it's the same exact problem on the test. Simple modifications of what we talked about today are certainly within this realm of possibility. How about coordinate change? You guys ready for coordinate change? I got lots of coordinate change on the test, I'm pretty sure. You can calculate Jacobians and change to polars and sphericals and cylindricals. You guys are good to go on that stuff? What's that? I mean, is there a specific question you guys have about them? Coordinate change is not a specific question. What do you want to mate? I'm looking for a woman. I guess that's somewhat descriptive these days, but anyway, yes. Other question? All right, well, it was easy. Next.
This is not having to do with switching bounds or any of that, but it's just kind of a theoretical out of curiosity question. Back on, like when you're doing, like, you have that whole like B equals blah blah blah. If it's less than, then it's a saddle. If it's greater than, an f of x. Okay, so is there a possibility that b could equal 0? If it could, then what would that look like? What is that?
Something.
What would you have on
Oh, use common sense. So if we were to look at z is equal to, say, the cosine of xy, is my go-to example. Or you could do something snazzier like, heck, x squared, y squared, there. Even funner. Funner's not a word, then why did you know what I meant? 1 minus 1/2 x squared y squared squared plus dot dot dot. So like, check this out. This is 1 minus 1/2 x to the 4th y to the 4th plus dot 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 dot. The first non-trivial term beyond the constant term in the power series expansion for this function is at 8th order. So not only is the Hessian vanishing, the 3rd order, 4th order, 5th order, 6th order, and 7th order stuff in the power series is also vanishing. But this you could figure out as a local maximum just from some common sense, right? This 0, 0 is a critical point, right? So if I said that this is f of xy, just to give a name, the gradient of f at 0, 0 is equal to 0, 0, so it's a critical point, right? And f of 0, 0 is equal to what? It's equal to the cosine of 0, which is 1, right? But it's cosine. And that's as good as it gets for cosine. Like if the cosine is making $1, it's like, yes, done. That is, I have achieved my maximal earnings. $1. If we're working in dollars, but anyway. So like, yeah, that's a maximum. Because it's cosine. I don't need calculus. But the more honest answer to your question is if d is equal to 0, you could consider paths. Go back to our idea about path limits and just look at different paths approaching. If you find one path where it's taking values above the limiting, above the critical value, and then you find another path where it's taking values below the critical value, then it's a saddle. And then otherwise you have to consider all possible paths. And yeah. Yeah, the indeterminate, right? The second derivative test is just mute. It's silent in the case that it's 0. It's got nothing to say. Yep.
So you get the maximum from the fact that your first term is an even power thing.
Oh, right. That's a good point. Is that, but then we add 1/4 x to the 8th, y to the 8th. But then you could well be like, whoa, but x to the 8th, y to the 8th is like super tiny compared to x to the 4th, y to the 4th, and you'd be right. Which is why, even though you're adding, it doesn't undo the subtracting, which is why it, in fact, is. But anyway, again, its cosine of 0 is 1, so it can only get smaller. It's cosine. But what it means geometrically is that like the tangent plane to such a point is kind of like it's really smooth. It stays close to, I mean, it kind of just, it's really smooth on there. Yep.
The solution for mission 6 can be up for review.
Did I not post it yet? I thought I posted the solution to mission 6. Please tell me I've posted the solution to mission 6. Someone here would have told me I hadn't posted the solution to mission 6, yes?
You're assuming we checked.
Well, I mean, you had a week to study. I mean, it's there? Okay. Phew. Oh, this is just the test. You guys don't want to look at that. Anyway, okay. Put the solutions up for the test? Do you really want my solutions for your test right now? You don't. You really don't. Do you guys know how to calculate averages? Center mass? Centroid? Okay. The moment of inertia I give to you, I don't expect you to know that off the top of your head. If I was to ask about that. Yep.
If you do put like a center of mass or centroid problem on there, like if you put one of them on there, are you probably going to put the other one on there? Is it probably going to be like one or the other?
What do you mean?
Well, they're like the same, but one's more involved.
Oh, right. I mean, see, now I feel like you've challenged me to put two of them on there. I don't know. Can I do that?
Well, we're just asking because, like, if, like, we know how to do it and you put two of them on there, then it's like, oh, win for us, two problems that, like, we know for sure how to do.
Well, you know, that question, it's not really about, I mean, what is that question about? Is it really about center of mass or centroid? No, not really. It's mostly about integrating. I mean, well, okay, maybe there's like a little symmetry thing there, like find the centroid of a half circle. Haha, stupid student, waste all your time to calculate the x. But the x is obviously 0 by symmetry. Ha 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 ha, stupid. Not really my aim here. The thinking is probably more on the side of, you know, making the right change of variables or finding bounds or the min-max stuff, of course, requires thinking. Yep.
Could you like do a problem where like you can't integrate it directly, so you have to swap the bounds?
I'll sort of do that. How about the region we're looking at is this. So let's just set it up both ways. How about that? How would you set this up as a type 1 region? We integrate from 0 to 1. We integrate from x to x over, x over 2 to x of f of xy dy dx, right? Because if you think about a typical, you know, point, it's somewhere between it's somewhere between y equals x over 2 and y equals x, okay?
Sorry.
It's okay. Now, the other way, look at that. I'll have to break up into two cases, right? So the first case, where is this point right here? 1 comma what? What's that? The y coordinate there. One half, right? So I have the integral from 0 to 1/2, and then what does x do? It goes from the left x is y, the right x is what? It's 2y, actually. One half, the 1. Okay, up here, the left x is still y, right? But what's the right x now? It's just 1, right? So if you're, and then you can come up, of course there's a long list of problems where you pick f of xy, which makes, say, a type 2 integral work, whereas a type 1 wouldn't, or vice versa. So now telling you a specific example where that happens right now is above my conceptual limit at the moment. We could look it up, like 1 over 1 plus x to the 4th, or sine of x squared, or typical things, but yeah. Yep.
Why do you have to change sign in that situation? Like, why can't you just say
Well, the point is that we can either set up the integral in one of those two ways.
okay, so you don't have to change the
It depends on the question. I might ask you a question that says set up this integral as both, it says type 1 and also as type 2. Show me both ways to set it up. That's a possible test question. Sometimes I force the issue by giving you an integrand, which you simply cannot do the first integral in the type 2 or type 1 integral. Maybe f of xy is something like, sine of y squared, right? So you can't do that y integral. But if you do the x integral first, right? The integral of sine of y squared dx is going to be x sine of y squared, right? Because sine of y squared is just a constant with respect to that integration. So you can do that, and then maybe after you do that, you reorder the bounds, then you can do the integration. At least the first one, and maybe the second one too. So the bottom line is recasting as type 1 or type 2, vice versa, whatever you have, it may make the first integration possible where it was impossible beforehand. Thanks, guys. I will see you tomorrow.